Alrighty, so your lesson today is going to be 2.5, and it's going to be fundamental theorem of algebra. Okay, and so what we have to begin with is if f of x is a polynomial of degree n such that n is going to be greater than 0, okay, so our degree is not going to be negative here, then f of x has at least 1 0 in the complex number system. Okay, so this means real, imaginary, or both, right? So, and what we had originally talked about, I feel like this question came early for us, but essentially if a plus bi, so if that complex number is a 0, then its conjugate, which should be a minus bi, is also a 0. Now, this we talked about on the board earlier this week, possibly, when I worked out that one homework problem, because I think that was honestly assigned early to where we hadn't talked about it yet. Okay, so essentially we're going to get to that point. Now, right now, we're simply going to find factors, and then we'll get to exactly how this plays out. So, A is going to be find zeros, and then you are going to write the polynomial as a product of linear factors. Okay, that's just the fancy way of saying write it as factors. Don't multiply out, but write it as factors. Okay, you have 0 is equal to x to the 4th minus 625. Okay, this is actually a difference of squares. So you have 0 is equal to, I have x squared plus 25, and then x squared minus 25. Okay, and so now that I have my factors, I'm going to set them each equal to 0. So I have x squared plus 25 is equal to 0, and I have x squared minus 25 is equal to 0. On this first side, I have x squared is equal to a negative 25, and then because I am going to take the square root, right, I need to make sure that I apply that plus or minus on the outside 5i. Okay, then here I have x squared is equal to 25. This one I too will apply that square root because I am applying it. I have x is equal to plus or minus 5. Okay, now these would be my zeros. At this point, I have zeros. These are not my factors, right? Here and here. So when I create my final function of factors, I have x plus 5i, that would be that negative one. I also have x minus 5i, that would be the positive one. I have x plus 5, which would be my negative 5, and then x minus 5, which would be my positive 5. That would be writing it as a product of linear factors. Okay, we have example 2, which is 0 is equal to x squared plus 10x, plus 23. Now, I'm going to save you the trouble and just tell you right now this is not factorable. Okay, so what we need to use is our quadratic formula. I don't care how you memorized it, song or anything, but you need to have it memorized. So I have the negative boy was unsure to go to the rad party, b squared, and miss out on 4 awesome chicks. The party was over at 2 a.m. That's how I learned it. All right, here we go. Now my A, not that color. My A is equal to 1 because it's coming from here. My B is equal to 10 because it's coming here. And my C is equal to 23 because it's stemming from here. And now I'm going to plug in. So I have negative 10 plus or minus the square root of 10 squared minus 4, 123. All over 2 times 1. Okay. I have the negative 10 plus or minus a rad 8 over 2. Now, I do need to simplify here. So right now, I have rad 8 is going to equal to rad 2, sorry. So now I have negative 10 plus or minus a 2 rad 2 over 2. Now, I can either just already realize that 2 goes into 10 and 2 will go into 2. Or I can say, and how the book will show you, is they take out a 2 on the top. Oh, that should be 5. Plus or minus rad 2 and then over 2. Okay, they factor it out first. If you can already see that, there's no need for you to worry about that. Okay, and then I have that my answer is a negative 5 plus or minus rad 2, right? Here's where that factor starts to come into play. So when I write it out as its factors, I have x minus, my first one is going to be a negative 5 plus rad 2. And my second one will be x minus, and this time I'm going to use the negative rad 2. So negative 5 minus rad 2. This is what I went over on the board. Okay, now our last example that we're going to do will be a bit longer, okay? And what we have here is example 3, which is find zeros of f of x is equal to x to the power of 4 minus 3x squared, cubed, plus 6x squared plus 2x minus 60. Okay, given that 1 plus 3i is a 0. Okay, where do I go from here? Well, I can create 2 factors. Okay, and what I'm going to do is I have 1 plus 3i, and I also have 1 minus 3i. And I know these 2 exist simply because it is a complex number. Okay, and so what I can create here is I can go x minus, my first one is 1 plus 3i. And then I can say x minus 1 minus 3i. Well, if I distribute this negative here and here, and then here and here, what I now get is I have x minus 1 minus 3i, and I have x minus 1 plus 3i. Okay, and what we're going to do is we're going to group this so that it becomes essentially factored out difference of squares, right? I now can create x minus 1 minus 3i times x minus 1 plus 3i, right? I have the same a, which is x minus 1, and I have the same b, which is 3i, but I have a positive and I have a negative. So at this point, I'm going to FOIL or distribute, however you want to look at it. Now, if I can tell that this is what it's going to look like, I can just multiply the a's and multiply the b's and be done with it. Okay, but if you need to go through the whole process, let's go through it. So I have my first is x minus 1 squared. My outside is going to be a plus 3i x minus 1. I have negative 3i x minus 1. And then I have negative 9i squared. Now, these are going to cancel. And so what I have now is I have x minus 1 squared. The I squared is equal to a negative 1. So that's really plus 9. Okay. At this point, I'm going to figure out what this comes out to. So I have x squared minus 2x plus 1 plus 9. Okay, which is x squared minus 2x plus 10. This right here is a factor. And I know that because I multiplied 2 of the zeros. So from the original, I am going to now use long division to factor out what I just found. Okay, so let's set this up. On the outside, I have x squared minus 2x plus 10. Going into, what was my original question? I have x to the power of 4 minus 3x cubed, whoa, plus 6x squared plus 2x minus 60. Okay, first part, what will get me to x to the power of 4? I have x squared. Okay, and then multiply it back. So I have x to the power of 4 minus 2x cubed plus 10x squared. Remember, you have to go through and change all the signs. So this is negative, positive, negative. Okay, what I get is canceling here. I have negative x cubed minus 4x squared, and then I'm going to bring this guy down, plus 2x. Okay, next one, I'm still using this. So I have a negative x. Negative x cubed. Is that a negative? Yeah. Plus 2x squared minus 10x. Okay, go ahead and change all of the signs. So addition, negative, addition. All right, this will cancel. Great. I have negative 6x squared and then plus 12x. Okay, my next one, still using x squared to decide. I have negative 6. Okay, and so let's send this back through. Oh, wait, I forgot to bring down my last portion, which is going to be minus 60. Okay, I have, coming back, a negative 6x squared plus 12x and then minus 60. But I have to change the sign of everything. So addition, negative, addition. Okay, this will cancel. This will cancel, and this will cancel. So I'm left with a remainder of 0, which is great. Okay, at this point, my new function that I still have to find zeros for is going to be x squared minus x minus 6. When I factor, I have x minus 3. I have x plus 2. And so now I have zeros of 3 and 2. Okay, so if I wrote out all of my zeros, I would have 3, 2, and then the original ones I had, which is 1 plus or minus 3i. If I wrote it out as factors, I have, what did I just do? X minus 3, X plus 2. I would do, and then I don't necessarily want to write these separately because I've already figured out what it is, which is x squared minus 2x plus 10.